Hello 108 class, Mr. McHugh back with you. Gizmo, my BT Boston Terrier, is getting tired. He's laying on the floor. He's exhausted from working all day. It's a rough job being a dog in a suburban neighborhood. So with that said, here we go. You and I, we have to keep working hard here. Example 6 here on page 3 says equations with degree equals 3, meaning the exponent is taken to the third power. Now when you first see that, you might start to say, whoa, we don't solve any of those. And I would be a little concerned, except I start to realize, well, what if I move the negative 6x over to the other side and set it equal to 0? We've been doing that with quadratic equations, and I'm looking at this, and another thing I kind of realize here is we don't care for negative 1 in front of the leading term, so I multiply everything by negative 1 or switch all the signs from a negative to a positive. Okay, now again, if you multiplied everything by negative 1, that would switch the signs. Okay, that's just a good do. We like to solve with the leading term being a positive. Okay, once I've done that, I'm looking at x to the third minus x squared minus 6x, and it sticks out to me like a sore thumb. I see the x in every term, and guess what? Rule number 1. Pull out the GCF. When I do that, now I've got myself a quadratic, a trinomial, and the leading x is a factor, so I put parentheses around that. A lot of students get a little trouble with that. Just think of it as parentheses around that. Can you factor the trinomial? The answer is yes. You're going to use reverse FOIL. You guys know the drill. This one's pretty easy here. Factors were 2 and negative 3. Again, always make sure you check them. Outer inner add up to negative 1x. Okay, now instead of having 2 sets of parentheses equal to 0, you've got 3 of them. So each of these factors, again, multiplication going on between them, has to give you a 0, so you produce a 0 coming out. So take each parentheses, set them equal to 0, and voila, solve for x. Add, subtract 2 on both sides here, add 3 to both sides, and there's your solution. Okay, so there you go. That's just in case they trying to mess with you a little bit. No big deal. Just factor out the GCF and you're on your way. Okay, example number 7. Here's an application problem. Oops, let me just put that about right here. And what it is this is example 7. You have a parallelogram, and these are these word problems that they tell you that the base is 8 meters more than the height, and the area of the parallelogram is 48 meters squared. Okay, this is on page 347. You can read that there, and that piece of sheet metal there they're working with. And our task is, can we find the height and the base of this parallelogram? Okay, so again, you got your MSI hats on, your math scene investigators. You are drawing a little diagram. You're given a relationship that the base is 8 more than the height, so let x be the height. The base will be represented by that relationship, x plus 8. The area of a parallelogram, you go back in your math toolbox and you remember that it's the base times the height. And that's because, by the way, you see that triangle right there? If I picked that up and flipped it around, I could stick it right here, and that would make, here's my base and there's my height, and I just basically got a rectangle. So that's why that's the area. Now we know the area was told to be 48 meters squared. The base is x plus 8 times the quantity, times the height x. So you write that down, and what hits you next? Hopefully you think of distributive property, and when you do that you get 48 equals x squared plus 8x. Okay, what are you dealing with? That's what you always got to ask yourself. And so you say, well, I see that exponent is a 2, so it's a what? A quadratic. Why not minus 48 on both sides and have a 0? Now, is it any big deal that the 0 is on the left? Nah, it's alright, leave it there. You still got a standard form or a quadratic, aka trinomial, set equal to 0. Solve the quadratic equation. How do you do that? Take the trinomial and do what, class? You got it. Factor it. Okay, that's why chapter 6 was so important. What's the right combination? X minus 4 times x plus 4. You can verify the outer and the inner for you. Make sure it comes up with 8x, but make sure you always do that right. Just don't pick anything. Okay, you've got that. What do you do now when you get two sets of parentheses multiplied together equals 0? Here we are. Set the parentheses equal to 0. X minus 4 equals 0. X plus 12. Solve for x. X equals 4 and x equals negative 12. Whoa, whoa, whoa. Negative 12. You check your work. We reject it. Why? Because in the physical measurement you can't have a negative length. So the base is, x is the height. So height equals 4 in this problem. The base was 8 more, so we said 8 plus 4 got 12, and there's your answer. Okay, doing good here. Next example here is a rocket being launched off, and this one's going to be a little dear to my heart here for a second. Let me kind of help you out here. This is on page 348. I think it's the exact same problem. Yes. Okay, this is page 348. And the reason I make a big deal about this, I was a system engineer and a contractor for the Navy back in the 80s, and then in the 90s I worked for the FAA. Then I came back to the Aegis project for the Navy back in 2000, and in between there in the 1990s, way back, I can't believe how fast time's going by, but the Gulf War happened, and Iraq and Saddam Hussein were firing Scud missiles. Some of you guys might remember that. Scud missiles are ballistic missiles that basically you have a launching pad, you angle them, they come up, the fuel takes them up to the top, and this is called a parabola, comes down, and the Aegis ships that I was working on were modified. Here's an Aegis ship here, and we launched missiles to go and intercept. And so these parabolas are a big thing for me, helping to work with the ability to protect areas of our interests and our own. Kind of a big deal. So it's just a small case where you could see mathematics that you learned today. The parabola, it's all programmed into computers now, and the radar's tracking them. But basically it boils down to figuring out that quadratic equation of that missile. And this is just an example of taking a rocket, and its speed is 128 feet per second, and you're given that the height, based as a function of t as time, is negative 16 t squared plus 128 t. Now that's given to you. You don't have to figure that out. The question is, what would if the height is 220 feet high, what is the time for the rocket to get to that? So go back to my diagram. This is the ground. Here we are at the ground, and up so far, pretend right here is 220 feet. The rocket has to come up at a certain amount of time, and the x-axis is time, maybe 1 second, 2 seconds, 3, 4. Then it's going to hit there at 220 feet, and it's going to keep going. Guess what? It hits the top at the vertex. That's the highest point. Gravity takes over. It again is going to hit 220 feet on the way down. So you're looking for 2 sets of times. Okay, so how can we get that? Well, once you kind of understand what's going on here, the height is 220. You're given a quadratic equation, so now you ask yourself, can you solve for t? And it's a quadratic, so I know I'm supposed to get it in standard form, and I see that negative 16t squared. I'm like, if I would add 16t squared, take it over to the left, minus 128t, take it over to the left, I would have the quadratic in standard form with a positive, and you want that positive leading coefficient on the t squared. Okay, now that you've done that, the challenge is, how can I simplify this? Now this next step right here, divide each term by 4s, because I see 16, 128, and 220. I like to teach it this way: divide everything by 4, because you maintain balance on the equation, and it reduces down to 4t squared minus 32t plus 55 equals 0. Now, some students were taught, and you'll see the book, they tell you to factor out of 4, greatest common factor. That's okay as long as you realize that it's a 4 and it drops when you solve for it. Some students have a big issue with that. So recommend you just look at this and say, if you find a GCF, divide by the GCF, and then you've got your algebra steps and your reasoning all make sense. You're not told to leave a 4 and let it hang out there. That bothers people. Okay, once you've got yourself a quadratic equation, Gotta use reverse foil. Ooh, somebody's firing off fireworks. I think tonight's the first night of the Boise Hawks baseball game here. My doggies are going crazy, so let me finish this up. So go ahead and look at the leading term. Take a 4, take a stab of maybe 2t, 2t. That's what I would try. Look at 55, come up with factors. -5 and 11 is what I tried. Again, do the outer and inner, make sure you come up with -32t, save some time, it does. Now I know you'll have to spend a little bit of work on that, but you got the idea, using reverse foil. What do you do now? The hard part's done. You've got the 2 sets of parentheses. Inside here, each of these parentheses, the zero factor property tells you take the parentheses, set them equal to 0, solve for t. You got the idea, add 5 to both sides, divide by 2, same thing, add 11, divide by 2, and you get your final answers. Okay, Mr. McHugh here, wrapping it up here for page 3. On page 4, I'd like you to take a look at it. I have taken this problem and written a diagram, not diagram, but graphed it, and I'd like you to take a look at that to see a parabola and to study it. So come join me on page 4 so you can understand how parabolas work. Okay, signing off for now, and I'll see you for page 4. Okay, goodbye.